First, we are going to see about the introduction of this assertion. Assertion checkers that verify specify properties specified properties of a design. Agree? Assertion checkers that verify specific properties of a design. These assertion checkers are instantiated in the design, establishing a single interface for design validation. Getting this one? These assertion checkers are instantiated in the design, establishing a single interface for design validation. So actually ovl is there for Verilog. In that 33 assertions are there. We have to instantiate in our code and we can do the validation. Okay. Then assertion checkers are instances of modules whose purpose in the design is to guarantee that some conditions hold true. For example, at a time only one grant should be high in the AHP multi-master bus, right? So we can use that as a condition, and we should check that that condition is hold true or not throughout the transaction. And one more thing, for example, 5.4, right? 5.4, the empty flag and full flag should not be high at a time. So this is another condition. So for this also you can use the assertion checker. Whenever this condition fails, then assertion will get fired, right? Now this is what assertion introduction. These assertion checkers are composed of one or more properties, message, severity and coverage. Properties in the sense that as I told earlier, empty and full should not be one at a time. And second, message. So once that assertion gets fired, you can give some message by using this one. And then severity will indicate you that how much severe this error is. And coverage will tell you that in that coverage expression how much that expression has exercised during that simulation. So this is all about the things which are all in that assertion checkers. Okay. First we are going to see about that properties. So properties are design attributes that are being verified by an assertion. So assertion, what it will do, it will going to check a particular condition. If that condition is hold true, then it will not get fired. If that condition is false, okay, in that in the middle of the transaction, so the assertion will get fired, right? So the condition we are mentioning with that assertion, right, that is called as properties. Okay. A property can be classified as a combinational property or temporal property. Okay. Here combinational property and temporal property. Combinatorial or combinational property is combinational property defines the relations between signals during the same clock cycles. But in the case of temporal property describes the relation between the signals over several cycles, possibly infinitely many. Getting this one? Combinational means within the clock cycle itself, what is the relation between signals? And temporal, we are going to see about assertion checkers benefit uses. How? Means testing internal points of the design, thus increasing the observability of the design, right? For example, the design engineers are writing assertions inside their code. Okay, so whenever the verification team found some bug in till design, So by enabling those assertions, the design engineers can easily debug, right? And one more thing, here we are mentioning properties. Those properties are depends on our implementation. Most of the things are depends on implementation, so it is very easy to debug, right? The second point, simplifying the diagnosis and the detection of bugs by constraining the occurrence of a bug to the assertion checker being checked. Getting this one? Simplifying the diagnosis and detection of bugs by constraining the occurrence of a bug to the assertion checkers being checked. As I told earlier, the same point they have explained here. Then allowing the designers to use the same assertions for both the simulation and formal verification. So we know that in formal verification, three methods are there. The first one is theorem proving, then model checking, and at last we'll have equivalence checking, right? Now, second one is what model checking, right? For model checking, they will use simple mathematical kind of things, and they will going to cross verify. That is called formal verification. One type of formal verification, right? So here the assertion properties we are using, right? The same thing we can use it for formal verification also. So these are all by these ways assertion checkers are benefit to users. Okay, next coming to this slide, assertion checkers address design verification concerns and can be used as follows to increase the design confidence. Combine assertion checkers to increase the coverage of the design, for example an interface circuits and corner cases. Getting this one? By adding the assertion checkers, it will automatically do that coverage, right? So automatically it will going to increase the coverage of the design, right? Then coming to the second point, include assertion checkers when a module has an external interface. In this case, assumptions on the correct input and output behavior should be guarded and verified. Yeah. Suppose you are designing one module. That thing will going to have an external interface. Okay. So if there is a bug, if you are writing the assertions with some assumption, for example you have designed that module. After the outside of that module we are having interface. That interface, inside that of module you are having that interface. That interface may have some problems, may have that bugs. Okay, but so for that, if you are writing the assertions in your module, it is very easy to debug, right? That's what here they are trying to say. Okay, next, it include assertion checkers when interfacing with third party modules. The same thing, but here we are including third party modules, since the designer may not be familiar with the module description, as in the case of IP cores, or may not be completely understand the module. In these cases, guarding the module with assertion checkers may prevent incorrect use of the module. Getting this one? So in our module, we are going to use this checkers, assertion checkers as a guard. Now we're going to see about checker parameters. So assertion checkers as its own set of parameters as described in its corresponding datasheet. The following parameters are common to all checkers. What are all those things? Property type, severity level, message, coverage level. We know all these things, right? Assertion checkers will going to have four common parameters. What are all those things? Parameter